let's go here. And trust me, guys, like after today, you should be proud of yourself, right? Like this is good level of detail to go in a week. Okay, so what is a flow in a fiber channel? We talked about this briefly. When we compare, and this is a very common conversation the moment you talk to any non-storage person. In fact, not just storage, any non-fiber channel person. Because people think about flow as a TCP flow or IP flow. In LAN or in TCP flow, the flow construct is very well defined, right? Even application developers know about a flow. They use a socket term, right? Like for people who have written networking code, there's a concept of socket. You make a socket, then you open a connection, and then you start doing whatever you want to do on top of that. And what is a socket, by the way, in TCP? It's a 5-tuple, the source IP, the destination IP, the source port, the destination port, and then we have the higher level protocol number. For TCP, it's 6, or UDP, it's something 17 or something like this, right? So basically, in TCP, it's very well defined. In fiber channel, it's not. Uh, in fiber channel, think about when somebody makes a read or write, they don't even know the disk is sitting on a fiber channel, SAN, right? It's just a disk. Nobody knows it's a locally attached or it's over a fiber channel. So the whole concept of initiator target LAN is very specific to fiber channel only, right? And this is why it's kind of a non-standard thing. It's like, people had to come up with it. And I'm not saying we came up with in the very beginning. Obviously, Watana was the first company who came up with this whole kind of offering. So they came up with this flow concept. But the point is that it's not a standard thing like the way you see a TCP flow, because most of the guys don't even see this. But then we have to define it, because before collecting a metric, you have to define a metric of what, like IOPS of what, right? That's the basic question. Okay, so we looked at this picture. I'm not going to go in detail, but essentially, when we exchange these read and write commands, and now we have looked at the packet header, so we know, right, where these things are sitting. The initiator FCID and the target FCID are sitting in the FC header, the orange color, and then the LUN or the namespace are sitting in the respective SCSI or NVMe headers. Okay, and that's what makes our flow. So if initiator 1 is talking to LUN 1 and LUN 2, that becomes our initiator 1, target 1, and LUN 1 flow. Okay, and similarly for NVMe. And then in the NPU, what we do for every flow, we make records, right? We'll go into more detail of the records, but essentially this is how it looks. Not looks, but like kind of a logical representation. But then, I think, Ed, you asked that question a few minutes back that, hey, if I want to know the IOPS of the initiator, and the initiator is talking to 10 targets and 20 LUNs behind those targets, essentially 200 LUNs, do I need to find the IOPS of all the ITL flows and do a sum? Yes, that is one way of doing it if you want to make your life tough, but there's an easier way of doing that too. Because what we do is we maintain a tree-like structure, and then what that first level of hierarchy is become IT flow. So this would be IT flow. These would be ITL or ITN flows. The other level concept, this could be an initiator flow, so I flow, or a T flow, or you can call it as vSAN flow. These are loose concepts. I wouldn't write this in a document. This is only for understanding, or this can be port flow. You can totally argue that I'm taking it too far, but sometime it helps to understand the things better, right? So when you define a target flow, you can ask for any metric on the target. That's how it helps to understand this. Okay, so with that, let's go into NPU-DB design. So what are the design goals of it? It's hierarchical and it has relationships. Why? Because our networks are hierarchical and they have relationships with it. Okay, that's number two, it's totally flexible. Honestly, I'm a big fan of this design, and I'll show you some of the use cases that crazy questions that you have in your mind. You just need to figure out that query, fire it on the NPU, and it will give you the answer. Okay, it's aware of the topology. We see some of the examples before in the metadata that where the target count is 0 and where the target count is not 0, things like that. So it's aware of the topology. And it's scalable. I mean, 20,000 flows that we do on NPU. By the way, that's only a QA certified limit. We can actually do more than that. In fact, there are customers who are running more than that, right? Like, because it's not a hard limit, it's just a QA certified limit. Okay, the NPU actually, obviously it's a CPU, but it also has its memory. So what it does when it receives those headers, it calculates the metrics. Now you know how the metrics are calculated, and the metrics are actually stored within the memory of the database. And because of that, it's an in-memory database. The database is hierarchical in nature, and it's also relational in nature. So for those of us who have worked with relational database like MySQL, Postgres, Oracle, think of it's a smaller version, a light version of that. Like SQLite, I think that's a very close analogy for that. And then we have different views within it, right? So let's go into that. Yeah, why I wouldn't explain that why. It just makes your life simpler. Okay, so this is a very, I would say the first analogy that I used in 2016 when I explained it to somebody, that why do you need views? So think about this very simple concept that think of a 3D object like cylinder, right? And this is probably like what, elementary school math or something that my son is probably going to go through, if not this year, maybe a couple of years from now. But a 3D object, a cylinder, if I want to know the radius of the cylinder, all I have to do is just look at the top view. Okay, and if I want to know the height of the cylinder, all I have to do is just look at the side view of it, right? Like the concept of engineering drawings, that where do you look at from and then you get the number. Now, this may not make sense here, but if you extend this concept that now you have 1,000,000 cylinders and you want to quickly report the radius of all the cylinders, then why would you waste time like looking at all the angles of it? Like you just go and stand top of that, like, okay, let me calculate, zoop, zoop, zoop. That's going to make your life easier to report the cylinder. Of the radius of the cylinder. But let's say if somebody asks, no, just show me the height of the 200 cylinders. Now you go and look at the side view and you get the height of it. Right? So it's the same concept like cylinder, but I make the two, I would say, child of that object, and one is the top view, the other is the side view. And then I have some metrics within the top view and the side view. In the top view, I have a metric called radius, and in the side view, I have a metric called height. So essentially, it simplifies, it defines my scope, and it increases my efficiency when I'm doing those query lookups. And again, think in millions. All right, so let's bring that concept to our fabrics, our fiber channel fabrics. And by the way, this is our NPU looks like. Okay. Let's understand this. And then we'll solve some use cases with it. I'm not sure if we are going to run some commands today, but when we go on switch CLIs, you'll see that we run one command and we find a lot of answers. Like depending on what you want to know, just fire the command there. So here is our kind of like a hierarchy in relationships. And if I look at this particular port, which is the ISL port on my host edge switch, this port may be having a name FC1/1. Then I may have one or more than one vSANs flowing on this port. Let's say in this example, vSAN 10 and 20. Within the vSANs, I may have traffic going to different targets. So let's say in vSAN 10, the traffic is going to FCID W and X. And in vSAN 20, the traffic is going to target ID Y and Z. And then obviously these targets would be talking to multiple initiators, and finally those IT pairs would be going to different LANs behind those targets, right? So you see this hierarchy here? Now, if you want to know, obviously, if you want to know the IOPS of a particular ITL flow, let's say you can say, show me the IOPS of ZH24, right? This one. So you find the IOPS from here. Single query, you get your answer. But the next question is, you don't want to get lost every time. I mean, ITL level is just too much detail, right? So if you want to know the IOPS of Z, You can say to your question that I want to know the IOPS of a particular target port, which is Z. So one way of doing that is like you do the math of the IOPS of all these ITL flows and add them. And if you have 1,000 of these, imagine your life after that, right? Like doing this math all the time. You don't have to do that because in the NPU, there's a view for every target. Also, you send one query on that target ID Z and you find the IOPS. Okay, so this is the value of having different views. We have 13 such views. Just like target ID, let's say you want to know the IOPS of a port or throughput of a port, or you can say, let's say you want to compare the response times on two target ports on the same storage array. And one is significantly higher than the other one, that can be a valid use case. So to find the metrics at a port level, you use a port view. And this hierarchy is totally maintained within the NPU DB. Similarly, you can have a per vSAN distribution. If your ISL port is there and you have 4 vSANs carrying traffic on ISL port, you send one query to your vSAN view, and you get the throughput distribution per vSAN. Otherwise, if you start doing this math at every ITL level, oh man, nobody wants to do that after doing one time, right? Or probably somebody will end up writing some apps or scripts for that, but all that is integrated within the NPU. So that's one. The other thing is the views are topology aware. So the first view at the very top of the NPU DB, I mean, before I go there, let me show you that you actually get to see these views in the output of the commands. So you do show analytics schema view. No, FC, I need to use the protocol name and then. Okay, so these are the views here. Okay, these are 13 views. And then when you execute your show commands, the show queries, not the commands, you see that in this query, I am using select all. So all means every metric from the SCSI protocol on the port view. Okay, so when I do port view, I get some metrics, but I can, depending on my use case, let's say I want to know the IOPS of a port, I use port. I want to know the IOPS of a target, I use the target view. I want to know the IOPS per IT flow, I use the IT flow, or I can go and drill down at ITL level also. Okay, so this is where you get to see the views. And in this view hierarchy, at the very top, we have ports. So any analytics enabled port will have a view of its own. So on a switch, if I go and enable analytics on 10 ports, I'll have 10 views in that port. Depending on where the port lies, which NPU it belongs to, that NPU will maintain that view. But let's say for the sake of simplicity, just consider a fabric switch, or maybe consider just one module. I enable analytics on 10 ports, I'm going to have 10 views, because one port view for every analytics enabled port. Okay, next level is the vSAN. So because in Cisco MDS, you have to have vSANs all the time, you cannot disable it. That's why we'll always build a vSAN view. It can be just one, so the number of port view will be same as the number of vSANs view if there's just one vSAN on the port. But if you have more than one, especially on ISL ports, we're going to have as many number of vSAN views. Then the target. We only maintain target views if the target is accessible on the network side. We kind of covered this concept before. So when you run a command and you don't see any output, or you know what, so on this particular switch, this is actually a storage edge switch. So show floggy database. You see all these devices are actually target. targets, right? It doesn't show here because it's not an FCNS output, but and then I have ISL, so show topology, show interface port channel 2. I have two links. These are ISLs. Let me do this. If I do show analytics query and I do select all from FC SCSI dot, what is the name of the views? The SCSI initiator, SCSI initiator. I see some values, right? Now, the reason I see the values here because I've enabled analytics on my ISL ports. If I go back to my drawing, and if I look here, I'm actually looking at this switch, and I've enabled analytics on this port and this port. I've enabled analytics on all the ports. Okay, so that initiator view is coming out of this ISL port because I can access initiators from the ISL port on the storage edge switch. Now, as a next step, show run interface FC 1/15 and 1/16. See that analytics is enabled on all of them. Let's disable it. No analytics type FC all. So I disabled analytics. The moment I disable, all those initiator views get purged. They are not there anymore. So I shouldn't have the output of this. You see that table is empty. So when you get this error, think about, are you really running the query on the right view? Because our views are topology aware. But on this switch, I should move from SCSI initiator to SCSI target view because I've still enabled analytics on my target ports. Going back on this picture, I've enabled analytics on my target ports here. And on these target ports, we maintain every view that starts with target something. Okay, so remember when you execute the CLIs, show analytics query, you hit this thing, just watch out for. You be aware where this port is connected to. Okay, so essentially, hopefully it making some sense that why there's a hierarchy and how, I didn't really talk about how do you use it, but essentially remember, every view has a metric of its own. So these metrics are actually calculated in the records that are associated with the views. And the views are not going to be everywhere. They just really depends. Any view that starts with target is only populated wherever we see the target on the network side, and the same statement applies for initiator, right? So we have different views, so if your queries fail, don't worry, the data is still there, or data may be there if there's nothing else is wrong, but you just try the initiator view of that. At the very bottom of this hierarchy, we have the initiator ITL or the target ITL flow, but under that we have the open flows. These are these views that you see. We don't retain them. These are open exchanges. So let's say if it took 200 microsecond for a exchange to finish, this view will be there for 200 microsecond. So for normal humans, this doesn't exist, right? We can never access it. Or maybe when you run the command, you can dump the data, but this data would be all over the place. It's just used for internal calculations by the speed of the CPU. Let me show you, because it's too many slides, a lot of details. Let me show you one example, and then we'll go into detail of that how do you going to use the views to solve a problem and pinpoint the problem. So I do show analytics query and do select all from FC SCSI.port. Okay, these are too many metrics. And you're going to see that every port has its own record. And this is a key value format, and all these will go in detail. But now these are too many things, right? I don't want to go and check all of that. So I just limit the output from port. And then let's say read IO rate. And I can do um, sort read IO rate. So essentially I'm saying, show me all the ports on this switch with the maximum read IOPS in the descending order. I want the topmost port with the top IOPS at the top. And then don't show me maybe 100 ports. If I have enabled 100 ports, just limit the output to 3. Make sense? So I get, the moment I do that, I get my top 3 ports with the most IOPS. Single command. Okay, now look at this port. Wow, this is interesting. Let's drill down into further. So instead of the port, I can do a target. Is that the, no, what is the show analytics schema, FC, SCSI. Yeah, I'm just going to pretend I don't know anything, right? Because this is what you should be following. These things may change and I don't expect anybody to remember things. Right, so now you use SCSI target from here. Okay. Now I think the target that's connected to this port is actually doing a lot of IOPS. Okay, so actually, when I go to target record, I also get my target ID. No, let me not do any shortcuts. I want to show you things. You see this target ID? It wasn't there in the port view. It's only there in the target, the SCSI target view. So now I'm going to do read IO rate. Let's just stick to target ID. Okay. And then you can do a show FCNS database and figure out show FCNS database, FCID, this guy, vSAN 20. So I know, right? It's a more meaningful way. But now I want to drill down. Okay, this target port may be talking to 10 initiators, right? You want to know which initiator is the cause of that? Let's do that. So now I don't do SCSI target. I do SCSI target IT flow. And when I use that view, I get more records. I get an initiator ID also. You see that? Now there's a record for every initiator that is talking to this target port. Okay, so now along with target ID, I'm going to drill down at an initiator ID also. And it's the same query we are doing read IOPS and just displaying top 3 SCSI target IT flow. Okay, so the previous number that you saw, something called 10,000, this 10,099, out of these many IOPS, most IOPS are derived by this initiator ID. Second, this initiator ID. Third, this initiator ID. Okay, that's second level pinpointing. Let's go to the third level pinpointing. Now you want to know which LUN these IOPS are going to. So we use ITL flow record, and then because it's a LUN level record, I can have LUN2. Okay, so out of all the LUNs that this target and initiator, the target is talking to, the most is coming from this LUN. It's behind this target port. And by the way, this is the initiator which is driving this IOPS, the read IOPS. Right, so this would be a workflow and the use case for views that nobody's going to start from ITL. I mean, you can always do that. Like you can say that, hey, show me the most busiest LUN in my fabric, and you're going to run, this is the query you're going to use. But then probably you're going to start at the higher level at a port view that show me the busiest port. You could do this something for, let's say, bandwidth. I think the bandwidth for a fabric is going to be a more useful use case because bandwidth you're going to get from the switch view, right? Let's say if I have show floggy database here, and I get all these ports, right? And show interface brief. No, show interface, counters brief. Okay, so if you remember, see that here, right now, this is not doing much, right? Like obviously, how much can I do in my lab? But let's say this FC1/33 is doing 95 megabytes per second. Imagine this port was running at 90% utilization. Okay, and at that point of time, you want to know, hey, why is it 90% utilization? Who's consuming that? Who's chewing up the bandwidth? You could not find that answer before SAN Analytics. But with SAN Analytics, we followed a workflow, right? You saw that different views. I started from a port view, then I went to target view, then I went to IT flow, and then I went to ITL flow. And I can pinpoint, hey, you know what? Out of these 5 different LUNs, or maybe 50 different LUNs, this one LUN that is doing 50%, and the rest of the guys are just like doing nothing. So why don't we move that one particular LUN to maybe a less utilized port? So that's the use case that we can solve with all these details that we have been, crashing our heads and like frying our brains. But eventually it comes back and like it helps us to find the answer that we just tried to solve in last probably 5 minutes.
For us, just to be clear, right? We needed a where statement, right? Where target ID equaled a particular
Yes.
ID and where,
I missed that.
Yeah.
Thanks for catching that. You're already getting it, man. Yeah, I missed that. So I mean, let's execute the commands again. And when I did this command, the all from limit 3, so I could have done the target ID and read IO rate. And here, after going any further, I should have used where target ID equal to this value only. So now I'm specific for this target ID only. And thanks for pointing that out. Yeah, I was thinking, okay, nobody's catching that. Like, okay, these guys are going to think I'm lost. Yeah, but whatever. But thanks for catching that. And now when I go, so if I execute that, where target, yeah, so there's just one record, right? Like that totally makes sense. But then we can go target IT flow. And then here we also print initiator ID, right? So now I'm getting the target ID is constant. It's not changing because we limited our query for that. But now the initiator ID changes. So this is the initiator that's driving most IOPS. And then with using the where, I can do learn here. And ITL flow record and get the answer like this. Or can we do multiple ands? I don't think so. Initiator ID equal to, this is a very simplified implementation of the SQL. So if we just stick to this initiator and target ID, oh, it worked, right? So now both the initiator ID and the target ID are constant, but the LUNs are changing. So out of these two initiator and target devices talking, the most IOPS is derived by this LUN, right? Okay, so hopefully it's. I mean, I would say yesterday and today we have hit the ocean floor. Right now we slowly go to the surface again and see the realities of the world. Nobody cares about these JSON crazy details, but like they want to know, hey, tell me the app, solve me that number, 95% utilization, show me why. I think that's where it's important, but we won't be able to answer those questions unless we know these details. How do we handle with this? Or obviously, SAN Insights, is a simplified way of looking at the things. But there's a long journey, by the way. These metrics reach there and show up in those nice graphs,
I have a question. When we decide to, let's say from a deployment method, do storage edge only. The only way we're going to get initiator views is to enable analytics on the ISLs, correct?
Yeah, but you don't need initiator view. That's the point. You don't need all the views all the time. Right? If you look at this picture, you don't need, because your information is actually the same. I mean, the real information is sitting in these flows, right? And by the way, the metrics that you have, either target ITL flow record or the initiator ITL flow record, the metrics are same. So you don't need the other version of the view record. The reason it's architected like this, because remember, think about, nobody's going to, I mean, a lot of customers may not have end-to-end 32 gig infrastructure. They may get just one 32 gig hardware. So, we still want to provide that flexibility and use cases. And as people grow, bring in more 32 gig hardware and analytics enabled ports, we should still be able to provide them, but you don't need that initiator side of the view. You just noticed that, right? Like I was just running.
Back to Ed's earlier question, if I wanted to get all of the IOPS from an initiator, I would need the initiator view, right?
Well, we just did this, right? You see that? I'm just executing these queries on this SCSI target ITL flow record. It's not a SCSI initiator ITL flow record. I still get the initiator ID and the LUN value here.